A very warm welcome to our students. Today I am Dr. Rashmi Srivastav going to present you our very first chapter, that is solutions. So let us begin. What we see around is mostly like cloud, dust, mist, fog, ink, colored glass, milk, cream, etc. All are in the form of solutions. Here I have some solution. This is cold drink, this is syrup, this is glass. Is it not wonderful? Do you know what is solution? Well, you may have learnt it in your previous classes. Here it is for you. Dear students, I am preparing a solution and one component is mixing to other. This is solution of common salt. After today's session, you will be able to understand the concept of solution, types and their concentration units. You will also be able to understand how they can be prepared and calculation can be carried out to determine mass of solute, moles of solute and various units. Now, the solution is a homogeneous mixture having two components. One, solute and solvents. Solute. The component of a solution other than solvent is called solute. It may or may not have same physical state as that of solution. Generally, it is smaller in amount. Example, like aqueous solution of glucose have glucose as solute. Now, solvent. It is the constituent of solution which has same physical state as that of solution and generally present in greater amount than that of other components. In the aqueous solution of glucose, water is solvent. Solution as a binary and ternary mixture and even they can have more than two components. In the beginning, we have seen various solutions. Now, we will learn about 9 types of solutions. Let us discuss one by one. First, gas as solute in gas as solvent. Example, air. Second, liquid as solute in gas as solvent. Example, fog. Third, solid as solute in gas as solvent. Example, dust. Fourth, gas as solute in liquid as solvent. Example, carbonated drinks. Fifth, liquid as solute in liquid as solvent. Example, milk. Sixth, solid as solute in liquid as solvent. Example, glucose in water. Seventh, gas as solute in solid as solvent. Example, adsorbed gases. Eighth, liquid as solute in solid as solvent. Example, gel, jelly, etc. Ninth, solid as solute in solid as solvent. Example, colored glass. So, we can see that solution make our world beautiful, isn't it? Oh yes. Now, we are moving to the next level, that is concentration units. We can understand solution and its concentration units in two ways. First, either by preparing a solution of known solute in the given solvent, like I am preparing a solution of glucose. Here I am dissolving glucose in water. So, this makes a solution of glucose. Now, in this solution, we know the concentration of solutions. Here I am dissolving 2 gram of glucose in 50 ml of water. In this solution, we know the concentration of solutions, that is the amount of solute dissolved in the solution. 2. The second way is from already prepared solution that is given to you either in the laboratory or from natural sources like this aqueous solution of common salt. Concentration units. Well, it is the amount of solute dissolved in the given solution. It is of two types, physical and chemical. Physical unit. It gives direct measurement of solute. We are using this in our daily life at many occasions like adding sugar in charge, sugar in curd, amount of sugar in cold drinks, amount of component of medicines in tablets, capsules and in syrup. We will understand these in next few minutes. Chemical unit. It gives indirect measurement of solute in the solution. These are specialized units and are used in labs by students, researchers and scientists. Let us discuss one by one. The very first one is strength. It is denoted in gram per liter. It means that the amount of solute in gram dissolved in 1 liter of solution. For example, 1.5 gram NaCl dissolved in 100 ml water. Calculate the strength of solution in gram per liter. Here, mass of solute is 1.5 gram. Volume of solution is given in ml, that is 100 ml, and when we divided it by 1000, we are converting it into liter. So, it comes around 0.1 liter. So, strength is in mass per volume in liter. So, strength is 1.5 gram divided by 0.1 liter, that is 15 gram per liter. Now, second one is percent strength. Percent strength can be expressed in percentage mass by mass or m by m. It means that x gram of solute dissolved in 100 gram of solvent. Let us clear it with one example. 5 gram of sucrose dissolved in 100 gram of solution. Calculate percentage mass by mass strength of solution. For this, mass of solute is 5 gram, mass of solution is 100 gram, or we can also calculate mass of solute as 100 minus 5, that is 95 gram. So, percent m by m is equal to 5 gram divided by 95 plus 5 into 100, which is equal to 5 divided by 100 into 100 means 5%. So, it is 5% mass by mass solution. The second one is percent mass by volume. It means that x gram of solute dissolved in 100 ml of solvent. Again, example goes like that. 2.5 gram of glucose dissolved in 50 ml of solution. Calculate percent m by m strength of solution. The mass of solute is 2.5 gram. Volume of solution is 50 ml. So, percent mass by volume is equal to 2.5 gram divided by 50 ml into 100, which is equal to 5% mass by volume. Clear? It is a 5% m by v solution. Now, we will learn the third one, percent v by v or volume by volume. It means that x ml of solute dissolved in 100 ml of solution or 100 minus x ml of solvent. Now, 5 ml of alcohol dissolved in 200 ml of solution. Calculate percent v by v strength of solution. In this question, the volume of solute is 5 ml, volume of solution is 200 ml, or volume of solvent is 200 ml minus 5 ml, that is 195 ml. Then percent V by V is equal to 5 ml divided by 200 ml, or 195 plus 5 ml into 100, which is equal to 2.5% V by V, or the solution is 2.5% volume by volume. The third physical concentration unit, that is 3 parts per million, that is 1 part in 1 million part. Let us understand this by taking one example. 1 kg of table salt contain 50 milligram of iodide. Calculate the concentration of iodide in ppm. In this, mass of solute is 50 milligram, and when we convert it into gram, divided it by 1000, so it is around 0.05 gram. Mass of solution is 1 kg, which is equivalent to 1000 gram. Now, ppm is equal to given mass of solute divided by mass of solution into 10 raised to the power 6, which is equal to 0.05 gram divided by 1000 gram into 10 raised to the power 6, which comes 50 ppm. Dear learners, we can see here that how even the small amount of solute can be detected and determined in natural and biological system. These units are very important in diagnosis of biochemical components in medical science, agriculture and in environmental parameters. If we see the air pollution indicator of Delhi today, here different pollutants are expressed in ppm, like NO2 is 2.5 ppm, SO2 is 6.3 ppm, CO is 1.28 ppm, carbon dioxide or CO2 is equal to 7.35 ppm, etc. These data convey that 1 lakh air contain 2.5 gram of nitrogen oxide, 6.3 gram of sulfur dioxide, 1.28 gram of carbon monoxide and 7.35 gram of carbon dioxide. Now, you can compare these values with normal parameter and make a conclusion about pollution. After the physical concentration unit, we are going to learn about the chemical unit one by one. The first one is molarity. It expresses the moles of solute dissolves in 1 liter of solution. You know that the number of moles can be calculated as given mass of solute divided by molar mass of solute, that is capital M is equal to N by V, and where V is in liter. So, capital M is equal to W by M into 1000 if volume is given in ml. Now, again I am preparing a solution. This is 2 gram of NaOH dissolves in 250 ml of water. Now, calculate the molarity of solution. How to calculate the molarity? First, calculate number of moles. 2 gram divided by 40 gram mole. 40 gram per mole is the molar mass of NaOH, that is 0.05 mole. Now, convert volume into liter, that is 250 ml divided by 1000 is equal to 0.25 liter. Finally, molarity is equal to 0.05 mole divided by 0.25 liter. M is equal to 0.02 mole per liter. Dear learners, now we will study the next unit, that is molality. It is expressed in small m. It expresses the number of moles of solute dissolved in 1 kg of solvent. Again, the number of moles can be calculated as given mass of solute divided by molar mass of solute. that is m is equal to n by m kg is equal to W by m into 1000 mole gram. Let us clear this by one example. 0.6 gram urea dissolved in 100 gram of water. Calculate the molality of solution. Now, the mass of solute given here is 0.6 gram. Molar mass of urea is 60 gram per mole. Number of moles is equal to 0.6 gram divided by 60 gram mole, which is equal to 0.1 mole. Mass of solute is 100 gram divided by 1000, which is equal to 0.1 kg. Now, molality m is equal to 0.1 mole divided by 0.1 kg, which is equal to 1 mole per kg. That is, it is a 1 molar solution. The third chemical concentration unit is mole fraction. It is denoted by chi. In this concentration unit, it will give the ratio of mole of one constituent to the total moles of solute and solvent. The mole fraction of solute, that is x1 is equal to, it is equal to n1 by n1 plus n2. The mole fraction of second solute, that is x2, it is equal to n2 by n1 plus n2. The most important parameter is that chi 1 plus chi 2 is equal to 1. That means, if we know the mole fraction of one constituent, the other can be calculated. Chi 1 is equal to 1 minus chi 2. Let us work out another example. 3.9 gram benzene dissolved in 11.4 gram of octane. Calculate the mole fraction of benzene and octane. Now, how to calculate this? The mass of benzene, that is solute, is given 3.9 gram. Molar mass of benzene calculated is 78 gram per mole. The number of moles N1 is equal to 3.9 gram divided by 78 gram per mole, which is equal to 0.05 mole. Mass of octane, which is a solvent, and it is equal to 11.4 gram. Molar mass of octane is 114 gram per mole. The number of moles, that is N2, it is equal to 11.4 gram divided by 114 gram per mole, which is equal to 0.1 mole. Now, mole fraction of benzene is calculated. Chi 1 is equal to N1 divided by total number of moles, that is N1 plus N2. Now, chi 1 is equal to 0.05 divided by 0.1 plus 0.5. Chi 1 is equal to 0.05 divided by 0.15, and it comes out to be 0.67. These are the mole fraction of benzene and octane in the solution. So, dear students, we discussed a lot of concept today. What we discussed? Again, solution as a homogeneous mixture having two components. We have two different types of solution: gas in gas, liquid in liquid, solid in solid. We have learned the concentration units and the role in chemistry. Now, we will learn other concepts like solubility, Henry's law and Raoult's law, ideal solution and azeotropic mixtures. One example I am giving you to do in your homework. This is 2.24 gram glucose dissolved in 100 ml of water. Calculate the following concentration units. First is strength, second mass percent, and third is molarity m. Second question is 100 gram toothpaste contain 40 milligram of fluoride. Calculate concentration of fluoride in ppm. Third one is calculate the molality and mole fraction of a 10% m by v aqueous urea solution having density 1.2 gram per ml. We learn next concept in coming lectures. Goodbye. I hope you have understood the concept. We will learn next concept in coming lectures. Goodbye. Thank you. Take care.